We live in a world full of patterns. Patterns in sound, patterns in images, patterns in the choices we make every day. But how does a machine learn to recognize them? It starts with data, countless examples of the world, captured as numbers. A machine studies these examples again and again, searching for structure hidden beneath the surface. It notices what repeats. It senses what changes. It learns which details matter and which can be ignored. Over time, the machine builds its own internal map of reality, a map shaped not by rules we write, but by patterns it discovers. And with each new example, that map becomes sharper, richer, more capable. This is how machines begin to understand. Not by memorizing, but by recognizing. Not by being told, but by learning. The idea comes from us, from the billions of neurons inside the human brain. Each neuron is simple on its own, but together they create thought, memory, and intelligence. Inspired by this, we built artificial neurons, tiny mathematical echoes of their biological counterparts. On their own, they do almost nothing. But when we connect them by the thousands, the millions, the billions, something remarkable begins to happen. Patterns emerge. Decisions take shape. A system that once knew nothing starts to recognize, predict, and understand. Not because we programmed every rule, but because we gave it the ability to learn. The same fundamental idea nature discovered long before us. A neural network is a digital reflection of that idea, a system made of tiny units called nodes. Each node receives information, transforms it, and passes it forward, just like a neuron. But the real magic happens when these nodes are connected. Layer after layer, they form pathways, routes through which information flows and evolves. The first layers detect simple things, edges, colors, shapes. Deeper layers combine those pieces into concepts, objects, and meaning. With every connection strengthened or weakened, the network reshapes itself, learning which patterns matter most. It becomes better at recognizing, predicting, and understanding, not because it was told what to see, but because it discovered it. This is how a machine begins to interpret the world. One node, one layer, one pattern at a time. Information enters through the input layer. It travels through hidden layers, where the real learning happens. And finally, it reaches the output layer, where the network makes a prediction or a decision. But the journey doesn't end there. Each prediction is compared to the truth, and the difference between them becomes a signal, a guide that flows backward through the network. This process, called backpropagation, adjusts the strength of every connection. Tiny changes, repeated millions of times, slowly shape the network into something smarter, more accurate, more aware of the patterns it once couldn't see. With every cycle, the network refines itself. It learns from mistakes. It adapts. It evolves. This is how a neural network grows from raw numbers into a system capable of recognizing faces, translating languages, or understanding the world in ways that once seemed impossible. Every connection has a weight. These weights decide how strongly one node influences another. Learning is simply the process of adjusting these weights until the network gets better and better at recognizing patterns. At first, these weights are random. The network knows nothing. It guesses, it fails, it tries again. Each mistake sends a signal backward, nudging the weights ever so slightly. A tiny correction here, a subtle adjustment there. Individually, these changes seem insignificant. But together, over thousands or millions of iterations, they reshape the entire network's understanding. Slowly, the system begins to see structure where it once saw noise. It starts to recognize familiar shapes, familiar sounds, familiar behaviors. The chaos becomes clarity. The randomness becomes intelligence. This is learning at its core, a continuous refinement of connections, a gradual sharpening of perception, a machine discovering meaning through experience. We train a neural network by showing it examples. Thousands, sometimes millions. Each time it makes a mistake, it adjusts. Each time it succeeds, it reinforces what it learned. Slowly, the network becomes capable of tasks that once required human intelligence. What begins as raw data gradually becomes understanding. The network starts to recognize patterns it has never seen before, generalizing from past experience to new situations. Show it enough images, and it learns to see. Give it enough sentences, and it learns to read. Expose it to enough sounds, and it learns to listen. Through repetition, correction, and refinement, the system transforms from a blank slate into a model that can classify, predict, translate, or even create. This is the essence of machine learning, a simple process repeated at an unimaginable scale. giving rise to abilities that feel almost intuitive, yet are built entirely from data, experience, and iteration. Neural networks power the world around us, from recognizing your face, to understanding your voice, to helping cars see the road. They are the quiet engines of modern intelligence. They work behind the scenes, analyzing patterns faster than any human could, making split-second decisions that keep our devices responsive and our systems smart. They filter out spam before it reaches your inbox. They recommend the music you'll love before you've heard it. They translate languages in real time, bridge gaps in communication, and help doctors detect diseases earlier than ever before. Most of the time, you never notice them, but they're there, learning, adapting, improving, turning raw data into meaningful insight, and shaping a world where technology feels a little more intuitive, a little more human. A neural network is not magic. It's a system that learns from data, adapts through experience, and grows more capable over time. Just like us. This is how machines learn. This is the power of neural networks. And yet, the impact feels extraordinary. From simple mathematical functions, we build systems that can perceive, reason, and respond. Systems that can uncover patterns too subtle for the human eye, and make sense of information at a scale we could never process alone. They don't replace our intelligence. They extend it. They amplify what we can understand, accelerate what we can create, and open doors to discoveries we haven't imagined yet. In the end, a neural network is a tool, but one shaped by our curiosity, guided by our data, and powered by our desire to understand the world more deeply. This is the beginning of a new kind of partnership between human insight and machine learning, a collaboration that continues to evolve, one pattern at a time. Thanks for watching, and I'll see you in the next chapter of this digital adventure.